Assalamualaikum, my dear students. I hope all of you are fine and doing well. So, the topic that we are going to discuss today it is melting and boiling points of the transition elements. So, let's have a look at what does mean by the melting and boiling points. After this, we will discuss about transition elements. So, the melting and the boiling points basically these are the two main temperatures. Melting point is a simple temperature at which when we have a solid substance and it just convert into the liquid. This temperature is known as the melting point and that process is basically known as the melting of the substance. The solid this just going to be converted into the liquid state. But on the other hand, if we talk about the boiling, it is the simple change of the liquid into the gas phase or the vapors phase. This process is also called as evaporation and the temperature is called the boiling point at which that process is gonna to be take place. But on the other hand, we have also the reverse of these processes in which the liquid just changes into the solid. This process is called as freezing. On the other hand, when these vapors are changes into the liquid, this process is called as condensation or condensing of the gas particles into the liquid. Now here we will talk about the melting and the boiling points of the transition elements. Basically, transition elements have a very high melting points as well as they have very high boiling points. Now, why do they have high melting and boiling points? All that just depends upon their different properties. Like what type of main properties they have. They are very tough. They have strong metallic bonding. On the other hand, they have the involvement of d orbitals. All these are the main reason for which they have high melting and boiling points. So let's have a look on the simple melting points of the transition elements. You guys must know that what does mean by the transition elements. All the elements that are the group D and F elements or the group or the D and F block elements in the periodic table are called as transition elements and the transition elements are of mainly two types, typical and non-typical, and they are also inner and outer transition elements. Now here if we just have a look on its melting point, we just see that graphically representation along x-axis we have their atomic number and along y-axis we have their melting point that is in Kelvin, 10 raised to power 3 Kelvin. Now if we talk about the first series here, titanium, then we have vanadium, chromium, there is an increase in the melting point. But after chromium, when there is start of new series, there is a decrease in the melting point of the manganese, and then again from iron to cobalt, nickel, and then here we have the copper. There is again increase to decrease in the melting point of the transition elements. Likewise, if we talk about the second series in which zirconium to Nb, then we have molybdenum. There is an increase, but after this there is a gradual decrease and increase and decrease. All that is just because of there is involvement of d and f orbital electrons because some of them just have their orbitals like partially filled electrons in d subshells, and these subshells electrons are just involved in their bonding, that strong bonding going to be exist between them. But when we have look on the simple series of the melting point, gradual there is a increase up to the middle series and then after there is a decrease in the melting point of the transition elements. Likewise here you can see that there is gradual increase and then from tungsten to lower down platinum, and then at the end here we have the gold. There is a decrease in the melting point. Now, this is a simple trend because at the end they have fulfilled orbitals when we move from third, fourth to fifth series of the periodic table about transition elements. This was a simple trend of melting point. After this, here we have the trend of the boiling point of the transition elements. Here, the boiling point is the simple temperature in which the liquid changes into the gas phase. Now, the transition elements also have variations in their boiling point as well. Here, the melting and boiling point both are in the Kelvin along y-axis and x-axis we have atomic number. In this series, you can see that when there is an increase in the atomic number of this simple all transition elements. So here we have this is the boiling point in purple. There is an increase, gradual increase, but here you can see that at when we reaches at vanadium, then there is a decrease in the boiling point, and after the manganese, then there is also increase, and there is a then sudden decrease at zinc, and after zinc, when we just it is a gallium, and after the gallium when we start the germanium, and then there is also increase to decrease in their boiling points. So this is why, because all the transition elements have d subshell electrons, in which we have three blocks of the elements: 3d series, we have 4d series, and we have 5d series. And all these theories just have the variation of both the boiling points and as well as their melting points. So this is just because of the involvement of the d orbital electrons of their valence shell that do participate in the chemical bonding, and they are making up the strong bond which is called as the melting point, and the bond is known as the metallic bond. So to break this bond, we need high amount of energy in turn in the form of the temperature, whether the boiling point or the melting point. So this was all about today's lecture. I hope you guys understand. And if you have any queries, you may ask me about that in comment section, and I will get back to you guys soon. The next topic that we will discuss it is the covalent radii and ionic radii of transition elements. For that time, you guys keep learning and have a good day.